Okay. Instead of dealing with this, like, what are some choosing numbers that you know?
Like 5 choose 2.
Okay, what does 5 choose 2?
5 choose 2 is...
What number is
No,
it?
it's 15. No, it would be 10.
It's 10,
10.
okay. Alright, so why don't we erase this for a second. Up here. We'll keep our thing down here. Alright, so we know 5 choose 2 is 10.
And I would think of it as like 5 times 4 over 2 times 1.
Okay. Alright, so can we write that?
So you could write it as 5 factorial over 2 factorial times 3 factorial.
Aha. Okay.
So, it kind of looks like what we have here, but
It's
kind
sort
of
it's
flipped upside down.
Alright, that's fine. Do we have, do we have another choosing number that we know? That's off of our head.
You could, it's
Use
just
this,
that, I
like,
guess just a
4
small
choose-
example. We have 4.
4 choose... You just do 4 choose 1. No, it'd be 4.
Just 4 or 4 factorial over 1 factorial times 3 factorial.
Okay. So 52 choose 13 is going to be what?
So it's 52. That's not on screen.
So, 52 factorial.
Over 13 factorial times 39 factorial.
Alright.
So which is 1 over what we have here.
So it's 1 over 52 choose 13.
Okay. So this is an interesting question. So why do you think the probability that we found, and this was just for one suit, like for getting 13 diamonds or something, and you dealt them out, why would that be the inverse or the reciprocal of 13, 52 choose 13?
Well, 52 choose 13 is gonna be a positive integer. And we know, because we had a bunch of fractions that were all less than 1, and we're multiplying together, so we're gonna get a number that's less than 1. But it's also gonna be more than 0.
Okay, so at least we know it's between 0 and 1, that's good. But
So-
why would our probability of getting exactly 13, say, hearts, be the reciprocal of 52 choose 13?
So 52 choose 13 is the number of ways you can just choose 13 things from a set of 52.
Okay, so 52 choose 13 is the number of ways you can pick any 13 from a set of 52.
Yeah.
So that's, maybe there's a simplified form of a fraction on the top, because that's kind of our top.
Uh-huh.
It's kind of 52 choose 13. Because that's kind of what we're looking at, the number of ways to choose 13 things
Mm-hmm.
from a set of 52 things dealt. And then our bottom, which is which is total, I guess. I don't really know how to think about it in this way, but
The total number of ways to
yeah.
do that.
Well, okay, so we're choosing 13 things,
Yeah.
right? So what's the total number of ways to do that?
52 choose 13.
Okay, so 52 choose 13 isn't the top,
It's the bottom.
it's the bottom. Okay, so why don't you write that?
So if something over 52 choose 13.
And what does 52 choose 13 represent again?
That's the number of ways, total ways to choose 13 things for our hand.
Okay, now the top. What is the number of ways to pick all 13 hearts if you're picking 13 things?
Oh, there's only one way to do that.
Okay.
So then it flips into this.
So
So it's
this is our...
52 factorial over 13 factorial times 39 factorial, and the 1 over is going to flip it.
Okay, so now just explain, can you explain why the number we got is the reciprocal of the number of ways of choosing 13 things?
Well, the fraction here it's sort of like what you want. The favorable outcomes over the total number of outcomes. The total number of outcomes, total number of ways to choose the 13 cards from a deck of 52 is 52 choose 13, which is on the bottom here, so that's the total.
Okay.
But the number of ways to choose 13 spades, there's only one way to do that.
Okay. All right, cool. All right, so that was a brief detour through choosing numbers. Now let's go see our other way of dealing out the cards, and let's see if the order matters.
All right.